Hello Himanshu. So here is a video showing you how to test the 500 frames counter. So first I'm going to show you what you're going to need. So now there are a few things that you have to use on this setup. First thing is the SDR dongle from Sigfox. Also some attenuators. In this case I'm using two 20 dB attenuators with one 30 dB attenuator. These are from mini circuits. I recommend you to use some with a very high precision. These ones are 0.2 dB maximum variation on their values. So this is 20 dB plus or minus 0.2 dB. Two SMA cables. I'm using these ones. I've characterized the cables. They are around 0.9 dB of loss. You need one board containing the HT32SX. I'm using this one here, which is a red test board that we use here, and this is just a control board to the serial to get it to the computer. So you need a spectrum analyzer. You need also a PC that I will connect the dongle to it, right, like this. This PC will be running the RSA, the software, and another PC to run the termite serial, to send the serial commands. So in this PC I'm gonna run the termite. Okay, let's get started. Okay, now we're going to boot up the PC with the dongle connected. Okay, so we'll turn on the PC. So I'll just wait until it pops up the Linux here. So I'll just try Ubuntu. Okay, and then I will just open this software here, which is the RSA. Now I'm gonna set it to RC6. I'll put it downlink, and there, here I'm gonna put 5, 10, and 1, and the 3 below here. I've already told you how to do that. Then here and on the left side we can start one test, which is the next step is UL RF analysis nominal voltage. So this is the next step. So the first thing in this setup is to calibrate the frequency offset, just in case it's not calibrated. This is gonna get out of the factory calibrated, okay? So the next time we send you purchase samples, it will be already calibrated. But just to make sure for this test, it's important to verify the frequency offset. It might vary a little bit, which is not that hard, not a problem, but we just have to make sure that everything is fine. So I connected the HT32SX to an SMA cable directly into the spectrum analyzer. There's no attenuators here because our spectrum analyzer can go up to 30 dBm. So make sure that your spectrum analyzer is not hurt by any high signal that you put it in. So I'm not also sending a high power signal here. So just make sure that your spectrum analyzer supports this. If not, put an attenuator on here, which will have an error, right? Due to the attenuator's precision. That's why I'm connecting it directly, and I'm gonna send 4 dBm, just to have a reference. So right now I'm going to connect this control board here to the USB of this computer. So you have the USB here. I'll just put it on the serial port, USB port. I'll just close these things, start the terminal, the termite, right? And then I'll clear just this garbage that was there, and then reset. I'm gonna reset the sample. Once I reset, it starts the firmware, and it tells you at what frequency offset you're at. At this point, it's 2500, which is just the default value for this firmware. And the RSSI, which we will also calibrate, is set by default to -20. So let's calibrate the frequency offset. So the first line we're going to do is node config RCZ space 6. So I'm going to set it to RC6. Okay, so switch PA0. He turned off the PA because I don't want to send high power. If you need to send high power, you just use the function, the command node reduce output power and put it into -33, which is the maximum, right? So I'm not going to use it that for now. I'm just going to send the frame. So node send test frame and then the frequency, which is 865.2 megahertz. So I want this frequency to get on the spectrum analyzer. So right now it appeared on here. I'll put a marker on the pic, and as you can see, it is not calibrated. I did that on purpose just to show you how to do the calibration. So the calibration equation is shown on the screen right now. You just have to follow. So this is the measured frequency, and the desired frequency is 865.2 megahertz and not 199 like this. So in order to calibrate, I will apply this equation in this calculator here. It's just a simple calculator. So this is the desired frequency. I'm gonna subtract that from the one that is on the screen of the spectrum analyzer. That gives me, as expected, 1K, right? I have to divide that by 2, and that's 500. This is the value that I must add to this value here that was previously calibrated. If you do not remember what offset you're at, just use the function or the command get frequency offset, and then it will give you the offset that you're currently at. So we're currently at 2500. I'm gonna use a set, not the RSSI right now. I'm gonna set the frequency offset to 2800. Actually, it's plus 500, right? So it's to 21. So I'm gonna put 21. Okay, so I'll just do a get frequency offset just to make sure that 21 was applied. That's true right here. And now I'm gonna send a frame again just to make sure that it's calibrated. I'm gonna reset the spectrum analyzer. Okay, and now I'm gonna send the frame. So sending the frame. So I can see the marker is still there. So now it is perfectly calibrated to the frequency that we want. And now let's go to the next step. Okay, now we're going to calibrate the RSSI for the DUT. The first step in calibration of the RSSI is to set up the SDR dongle software. So the dongle is already connected. Here you can see the setup with two 20 dB attenuators. So the attenuation total here is 40 dB. Okay, these attenuators they have an amplitude variation of 0.2, which is very good, and I recommend you to use very precise attenuators. And then here in the software, what we're going to do is to set the test here to DL GFSK receiver. Okay, and then don't worry about the static drift at this point. It could be 0 or could be any other value. Just leave it as it is. It's not important. We are calibrating the amplitude. So now, before hitting start, I'm going to open the connection here. It's fine, and then I'm going to start. So here is the LED blinking. You can see here in the dongle. It's working. I'm not going to send frames right now because I have to set up the spectrum analyzer, and I'm going to show you how I'm going to set up the spectrum analyzer. Right now, it is set up to read a uplink signal, which is not what the dongle is going to send. So the center frequency was 865.2 megahertz. I'm going to change that to the downlink frequency, which is 866.3 megahertz. Okay. Also, the span, it was 200 kilohertz. I'm going to change that to 50 kilohertz because of the noise floor. You understand in a bit. The resolution bandwidth, I will leave it as it is. 1 kilohertz is fine. The most important configuration is the amplitude. As I expect to measure minus 100 dBm, which is for this 40 dB attenuation setup, I'm going to put this to minus 80 dBm. As you can see, the noise floor is still high, right? So I'm going to turn on the preamplifier, and then the noise floor has dropped. So now we can measure the downlink signal sent from the dongle. Let's start the frames. So you can see here on this screen, I'm going to just hit the start just as it is. And as you can see here on the spectrum analyzer, we have got signal in there, right? So the precision that you get in amplitude is a trade-off of your resolution bandwidth and your amplitude precision, right? So if I put here 3 kilohertz, there you go, you can see how you measure this frequency. So if I put here the RBW to 0.3 kilohertz, which is 300 megahertz, you can see that's a different measurement, right? So you can choose one of these. I recommend to put the RBW into 300 hertz, right? And you pick one of these peaks right here. The value is minus 98.3. I have to round that to an integer number because the RSSI that the DUT will answer will be an integer number, right? So minus 98.3, I will round that to minus 98, okay? So now we have to disconnect from the spectrum analyzer and put it on the DUT and see what is the RSSI that the DUT answers on the serial terminal. And then we have to calibrate that to the value that we have measured here on the spectrum analyzer. Okay, so coming here, I'm going to disconnect the dongle from the spectrum analyzer. I'm going to put it on the DUT. Okay, just making sure everything is still connected. Here we have stopped at this point here where we have sent previously a frame. Now I'm going to just put it into a downlink counter, and I put the frequency for the downlink, which is 866.3 megahertz, and this is the 2, which is the mode for receiver, right? Now, so as long as I press this, it will start receiving the frames, and it's giving me minus 101, so it's not calibrated, right? So I'm gonna change the RSSI of this sample. I'm not gonna wait until they finish the test. I'm just going to reset. So I'm back at the beginning. So the RSSI is minus 20. I'm gonna set it to minus 17, which is around 3 dB below 101 to give me 98, right? So as I have reset this sample, I'm first going to configure to the RC6. So config RCZ6. Fine. And now I'm going to set the RSSI offset to minus 17, which is 3 below the value that he has returned. I want it to be minus 98, which I measured before on the spectrum analyzer. And then I saw that the difference was 3, and then I subtracted, actually I added, right? If you consider this a negative number, it was minus 20, and then I changed that to minus 17. So let's set that, and then let's get the RSSI, just to make sure it has been applied. All right, it has been applied, and then let's start all over again. So I will start the downlink here in the DUT node downlink counter frequency. Okay, it's fine, and let's see what is the RSSI returned. All right, so the RSSI has been calibrated, and let's go to the next step. Okay, now we're going to start the test. The first thing to pay attention is you can select UL RF analysis nominal voltage again. Okay, and here we're going to send an uplink signal to the dongle. Okay, the setup is still with the 40 dB attenuators. Okay, connected to the DUT now. You can restart the RSA between these steps in this video. You can restart the RSA because sometimes it freezes the screen, and if the screen gets frozen when you're calibrating the RSSI, for example, you have to restart the RSA. It's not a problem. You just follow the steps. Okay. So now I'm going to open and start. Okay, it's receiving. Now I'm going to set up a command here. As you can see, the frequency offset is already calibrated to 21K. The RSSI is also calibrated to -17. Although the RSSI is just to have an idea of the received signal strength level, right? Because the DUT is not as precise as a high-performance spectrum analyzer. So the DUT is not a power meter, right? So it will have some imprecision for very, very low signals. That's why you need to use the spectrum analyzer as an auxiliary instrument in this setup. So I will start with the node config RCZ6. And then now I'm going to set the output power with this command here, node reduce output power -33 to send a very strong signal to the dongle and calibrate the static drift. Okay. And now I'm going to send a frame to the dongle. So let's see there. Actually, so these are 3 frames, right? So 3 frames. You can check the modulation. It's okay. And now if I change back to the DL GFSK receiver, you see that the static drift has changed, right? It's not 0 anymore, or it's not the same value as it was before, right? So it has been calibrated. Now I can just start sending the GFSK signal, but before doing that, I'm going to disconnect from the DUT, and I'm going to check the power on the spectrum analyzer with the 30 dB attenuation, right? Here, this attenuator here, I'm going to connect it here because I want to test the sensitivity of the device, which is, out of here is -98, and with 30 more, it's -128, right? We expect that, right? Plus the error of all these attenuators in series, okay? So, plus the loss of the cable, right? Actually, the loss of the cable was included in the calibration, but you have to know that there is an imprecision here. And then let's start sending the frames. Okay. So you can see there, it shows the frames being sent. So as you can see here in the spectrum analyzer, even with the preamplifier turned on, it's very hard to catch this signal. It's a very small signal, right? This is even for a high-performance spectrum analyzer like this one. It's very hard to catch the signal. So you should expect power measurement in precision on the DUT. So it will be not exactly. So for here, we can see that it's -127.8 dBm. It's almost 128. But you can see that it was hard for this spectrum analyzer to measure this power. And at the DUT, when we connect this to the DUT is not a power meter, right? So it will have an imprecision in reporting this measurement. So it will read the signal fine, but the report, the measurement that it does is not as accurate as the spectrum analyzer. So coming back to the serial commands here, I'll just put it into downlink mode. So the dongle is still sending the frames, right? So the downlink frequency, you have to remember, is 866.3 megahertz. And there's a 2 here to indicate the RX mode, the receiver mode. So there's a space 2 in the end here. So let's see and start running the test and counting the frame. So as you can see, the RSSI that's reported is -125, 24, 25. There's imprecision in this test, right? So it will count up to 500 received frames, right? And then it will count the ones that had failed and the one that has passed. And then it will report in the end. So I will stop right here and let this test run because it takes some minutes. and then I'll come back when it's finishing for you to see the result and the test being finished. So I'll come back when it's finished. Okay, as you can see, the test has finished, but there is one very important thing that has to be pointed out besides every detail that has been said already, and that is an SDR dongle limitation. We have measured every single frame together in a spectrum analyzer using a power splitter, okay, and we have measured that sometimes the dongle does not send the downlink signal, and on those cases the DUT will be open to Rx, but the frame is not going to be received because it has not been sent. This is not a receiver, it's not the receiver's fault, it's not the receiver degradation or anything. It's just that the transmitter, which in this case is the dongle, did not send the frame. As we have measured that happens, we adjusted this information here on the firmware that is printed for each frame, which counts the test index, and which is how many times the DUT has been open for signal reception, and the received, which are actually how many frames has been received by the DUT. In this case, this is a conducted test, right? And if we verify it with a power splitter in the spectrum analyzer, you can see the frames coming to the DUT and the spectrum analyzer at the same time. And sometimes simply the dongle does not send. So we count as 500 received frames, and how many of those has been failed at the limit of our device, which is the sensitivity. You can see that this RSSI is not actually the sensitivity because there's a limitation on the DUT power measurement, right? It's not a very specialized instrument for power measurement, but it gives you an idea. Once you have verified with your spectrum analyzer, you will be sure that it's operating on the sensitivity of the device, and here is your statistic that you required. So now we finish this tutorial at this point, and thank you very much for watching.